To change this expression and write it as a in terms of logarithms of x, y, and z, we need to recall the properties of logarithms. The first property of logarithms we're going to use says that the logarithm of a quotient is the difference in the logarithms. So the logarithm of base a of x minus log base a of y to the fifth square root z. The logarithm of a quotient is the difference in the logs. The next property of logs we use, I'm going to leave the first term alone, says that the logarithm of a product is the sum of the logarithms. So I'll write this as log base a of y to the fifth plus log base a of the square root of z, which we can write as z to the 1/2 power. I need this parenthesis here, the square bracket, to make sure I distribute later. Log base a of x minus log base a of y to the fifth. One of the properties of exponents we're going to use says that if I take the log of y to a power, I can take that power out in front. 5 times log base a of y plus, similarly here, 1/2 log base a of z. Last step is just to distribute the negative sign. So we finally get log base a of x minus 5 times log base a of y minus 1/2 log base a of z. So now we've used properties of logarithms to write this single log as a sum of 3 separate logarithms. Let's realize that we could have gone the other way too. I could have started with this expression and used those properties to combine them into one logarithm.